All right, hey Annabelle, I was just going to take a couple minutes to go over this. I was kind of looking over your quiz, and I just wanted to make sure you had gone over the PowerPoint for this section. Just make sure you take a look at that, and then maybe make sure that you take a look at the chats, just to make sure you kind of know what everything is, because this section does have a lot of mini-tab on it, and the more practice you get with it, a little bit easier it gets. All right, so it says using the data above, what's the least squares regression line of the data? All right, so what I want you to understand is this top row is always going to be your y values. The second row is always your x values. So when it says coefficient here, think about you have your equation y equals mx plus b. Since this is your y, this is like your coefficient of your y's. Well, there's no coefficient of your y's, but there is your y-intercept. So right here is your y-intercept. Okay, this papers is coefficient of your x's. So what's the coefficient of the x? That's your slope. So right there's your slope. All right, this is your standard deviation of your y's, and this right here is your standard error of your slope, or your standard deviation of x, which is pretty much the same thing. Okay, so this is your t ratio. So t ratio is basically just your test statistic t, and this is your p-value, your probability that your statistic is occurring. This you'll never use. S right here is your standard deviation of the residuals. Okay, your r squared is, you can find your r value from it by taking the square root of that. Okay, so just a couple of things to know from here. All right, so if we take the square root of 0.939, we're going to get 0.96. So our value is 0.96. I'm going to get that. Okay, and we never have to worry about this. All right, so what's the least squares regression line? So remember, you're going to do y equals mx plus b. All right, so y equals, what is your slope? Your slope is your 4.083, x plus what's your y-intercept? That's going to be your 35.8. Okay, so and that came from these two values right here. All right, then just always make sure you have your hat on y, because this is predicted, and you're going to want to define what y hat is and then what x is equal to. All right, so it says comment on the strength, direction, and percentage of variation explained by the line of best fit. Your strength and direction is going to come from your r value. That's 0.96. And just double check your slope and your r value are going to have the same positive or negative. So we have a positive slope here, so I know my r value is going to be positive, because since r squared is r squared, r could be positive or negative, and you would still get a positive r squared value. So you look at the slope to decide whether or not r is positive or negative. Okay, so it's 0.96. So what is the strength? So there is a strong, and then what direction is it? Positive relationship between the number of professors graded and the amount of money paid to the graders. So the percent of variation, that is your r squared value. Okay, so we have r squared equal to 93.9. So that just tells us that 93.9% of the variation, so if you take a look at your notes, it'll explain exactly how to do this, of the variation in the amount of money paid can be explained by the least squares regression line that relates the two. Okay, so let's take a look at the second one. So it says the second one, what we're doing is we are running an appropriate test to see if there's a correlation between the variables, and we're going to state our conclusion. Okay, so what we're doing here is we're basically running a test. All right, so we're checking to see is there some sort of correlation between the amount of papers that you grade and the amount of money paid. All right, so we don't know what to do. So what I'd like you to do is take a look at your 10.3 notes, and they're going to have like how to write the null and alternative hypothesis. So I'd like you to take a look at that to kind of get that explanation. If you're not sure, let me know and be happy to help. All right, so you're going to look at your null and alternative. Okay, your null is that the slope is equal to 0. So that's basically saying that there is no relationship at all between the amount of money paid to the graders and the amount of money, the amount of homework that you're grading. Beta is not equal to 0. Big beta right here, this is representing your slope of the population. Okay, so we're saying that there is no relationship, and beta not being equal to 0, saying that there is some sort of relationship between the amount of money paid to the graders and the number of papers that they're grading. So we're checking to see, is there actually in fact a relationship. Okay, so here, this is what you're going to do. So run an appropriate test, and then you'd say like all conditions are met. So this is like normally you do like your normal condition, simple random sample, and most of the time with linear tests, you're going to say all conditions are met. And the reason for that is the conditions are really long, so we don't want to go through and do them every single solitary time. So what do you need? Pretty much all you need is your test statistic t and your p-value. So the tricky part here, most of the time your t and your p-value will be given here. So how do we find that? Well, we have a formula that says the standard error of the slope is equal to t, I lied, is equal to beta over, or sorry, your slope over t. So the standard error of your slope right here is going to be the 0.9738 equals beta, not beta, I keep saying that, sorry, your slope. And what is your slope right here? It's your number in front of x, that's your 4.0835. all over t. So what is that test statistic t? So that's your test statistic t. So if you were to draw this, and here's your 1% alpha level, your test statistic t is saying like, here's your mean. All right, how far away is your test statistic from the mean? So that's what that t value is, okay? I'm actually gonna let you figure that one out. So you're literally just gonna solve for t and say t equals something. And then normally we'd be given our p-value, however we're not here. So just keep in mind that this is a test statistic t, so we're using our t curve. So we're gonna do this the same way we did on our graphing calculator. All right, so we're gonna do TCDF, just like we did in our other sections, and then whatever that t value is, comma, big number, okay, because we're checking to see if it's bigger, and then your degrees of freedom, so n equals 12 up here, so degrees of freedom in this case is always going to be n minus 2 because there's two variables, an x and a y, so comma 10. And that's going to give you your p-value, or the probability that that statistic actually occurs. That's all you need for this. Okay, and oftentimes it will give it to you. On your mini tab, it is always going to be two-sided. However, here in this case, it's only going to be one-sided, or two-sided if you do it from your graphing calculator. Right here, it's only one-sided, but since we're checking to see, it doesn't say like, is it a positive relationship, negative relationship? Since we say no relationship, we're going to multiply that value by 2 to get our p-value. So just keep in mind that this is always two-sided. So if your alternative is beta is less than 0 or beta is greater than 0, you'll actually have to divide that by 2. Okay, so here it says, find and interpret the 99% confidence interval for the slope of the regression line. All right, so the slope of your regression line is, or sorry, your 99% confidence interval, so that's our formula. The standard error of this, oh geez, sorry. Okay, your slope, because that's what we're testing. So when we create a confidence interval here, our confidence interval is going to tell us where the true slope of the population lies. So just like we did in the past with means and proportions, we're going to use our sample slope as the center of our interval. So it's the slope plus or minus your critical t-value, same thing that you did in your previous units, times your standard error of your slope. Okay, so let's pick out our values here. Here's our slope. So you have 4.083 plus or minus, and then your critical t, so remember we're doing a 99% confidence interval, so here's 99%, this is 0.05%, and this is 0.05. So on my calculator, I'm actually just going to do inverse t, since this is a t distribution of 0.995. We know that there's 12 data points, so degrees of freedom is n minus 2 is 10. So when I do that on my graphing calculator, sorry, it takes me a minute, 0.995, comma 10, I'm going to get 3.16. Okay, so that's my critical t, 3.16 times the standard error of my slope, and that comes from right here, 0.9738. Okay, and then you're actually just going to plug this in your graphing calculator. So you're going to figure out what that confidence interval is, okay, by just typing that in, 4 plus 3 times this, 4 minus 3 times this, get your confidence interval. And then your confidence interval, remember, is going to say we're 99% confident that the true slope of the regression line lies in this interval. The true slope of the regression line that relates blank and blank is in this interval. Does it support our conclusion? So remember, if 0 is in the interval, okay, that means there's no relationship. If 0 is not in the interval, there is some sort of relationship between the two. Okay, so down here, this one, is there statistically significant evidence to show there's a negative relationship in the wine consumption and heart disease? Okay, so this is the same thing kind of that I just explained. You're going to take a look at your null and alternative hypothesis here. Okay, so we're checking to see if you drink a certain amount of alcohol, does it lower heart disease? Okay, so when we make our null beta equal to 0, okay, that's going to show us, like, that's going to say there is no relationship between the two. When we say beta less than 0, that's going to basically say that we have a negative slope. And you always want to define what beta is. Beta is the relationship between the amount of alcohol that you drink and heart disease. Okay, so make sure you define what that variable is. And then all you're going to do, honestly, you're going to do this on your graphing calculator. So what you're going to do here is you're going to put this into L1. You're going to put this into L2. Okay, once you have that data, okay, you're going to say here, all conditions have been met. All right, because for these, we're never going to do that. You're going to go to stat. After you put that in L1 and L2, you're going to go to stat. You're going to go over to tests. And you're going to go down to, my calculator is number, sorry. So give me a second. It's letter F. Okay. And it's going to say Lin-Reg t-test. Okay. And you're going to hit enter after you get there. And then after you get there, what it's going to do is it's going to say, okay, put list 1 as X, list 2 as Y, frequency is 1. Make sure you have less than 0 for your slope. Calculate, and then notice what it does. Woohoo! When that does that, it's going to give you your test statistic T. It's going to give you your degrees of freedom. It's going to give you your p-value, and those are all things that you're going to want to include as part of your test. Okay, and then you can write your conclusion in the same way that you did before. And I like how you wrote this here, that there is a negative relationship in the wine consumption. I like how you stated that you're rejecting the null hypothesis because you're saying that it's so small it's practically 0. I just wasn't sure how you got that since you didn't have your test statistic or your p-value. You have great interpretation. Awesome job at staying statistically significant, and then saying that you'd have a probability of 0. So that looks great. Okay, so this one, we're talking about the same question. So take a look at this. It says, what's the value of the 0.9738? So let's find what that is. Okay, so this is, what did we say this was? We said that this is the standard error of the slope. Well, what does the standard error of the slope actually mean? It means if we were going to take a whole bunch of different samples, all right, here's one group of samples, okay? Here's another group of samples of 12 students. Here's the line. Here's another group of samples of 12 students. Here's the line. Every single solitary time you do this, your slope is going to be different. Maybe here it's 4.08. Maybe here it's 4.2. Maybe here it's 3.9. Every time you do this, you're going to get a different slope. So what does the standard error of the slope mean? That means that if I do this many, many, many times, the slope will vary from the population slope by about 9.9738. So when I do this many, many, many times, on average, how far is the slope of all of these lines going to vary from the perfect population slope? Okay, last two questions. I got 1 minute, and then my time runs out to do this. So which of the following would result in a violation of the conditions of inference for computer output? Okay, so definitely if all graders were selected from one professor, so that would not be a very good simple random sample. Okay, and remember here is the since we're using the t distribution here, we can have outliers because the t distribution is robust. So we'll just be careful with that. Okay, which of the following conditions must be satisfied in order to perform inference for regression of y on x? Okay, So the population values of x must be normally distributed. So the y values have to be normally distributed. So on that curve, okay, when we're looking at our line, pretty much there needs all the possible y values have to be normally distributed about the line. Okay, so the standard deviation of the y values for a given value of x is the same for every x value. So all that means is like your standard deviation of y values is going to be the same for every single one of these. Okay, so all these little normal curves you have, the standard deviation will be the same.